Hey guys, welcome to your notes on quadratic key features and graphing quadratics. So in this lesson, we're going to be talking about identifying key features of the graph, just like we did in class on our class notes, and looking at how to graph a quadratic function using our key features and what we know about our quadratic. So here we go. When we're looking at a quadratic on a graph, we can easily identify our key features. And the starting key feature is typically right here, and that's called your vertex. So this, we're going to go ahead and label our vertex. And this vertex is a minimum because the parabola opens up. The vertex is the lowest point or the minimum point of our parabola. Then we also have our, let me pick a different color here, our y-intercept is just the same as a linear function. It's where it crosses the y-axis. And so this y-intercept would be 0, 1. Oh, and our vertex would be at -1, -2. Let me cover that up with blue. Okay, so now the other things that we need to identify, and we should have done this right after we identified the vertex, is our line of symmetry. Because our line of symmetry is always attached to our vertex. And it splits the parabola down the center. So if I folded it, it would be identical on both sides. And that's important as we start graphing our parabolas, that line of symmetry, that our parabola is the same on both sides, so that if we were to fold it in half, it would be identical. So that's our line of symmetry. And then the last thing that we need to identify are our x-intercepts, or they are called several things as we talked about. So x-intercepts, they're also called zeros. And a lot of times you hear the x-intercept referred to as the zeros, so that these key terms are super important. X-intercepts, zeros, and they're also called solutions. So as we start solving quadratics, we'll start talking more about solutions, and this is what we're talking about, where it crosses the x-axis. The x-axis are our solutions for our quadratic. So in real life, some examples of parabolas you may see. The swing right here is a parabola, and it has a minimum vertex because it's opening up. But here, if you're shooting some hoops, you're shooting some parabolas, and you have a maximum, a maximum vertex, because it's at the top of your parabola. Okay, let's look at this first graph right here. We're going to graph the quadratic, label the zeros, y-intercepts, vertex, and axis of symmetry. So first we have to get it on the graph so we can label all these things. Now I'm going to point out a couple of things. First of all, your C value is your y-intercept. So I know that my y-intercept is going to happen at 0, 7. I'm going to go 2, 3, 4, 5, 6, 7. So I know some way, form, or fashion, my parabola is going to intersect the y and the y-axis at 0, 7. So I know that. The next thing I can identify is the the axis of symmetry using my formula that the formula chart gives me. So it says x is equal to the opposite of b over 2a, or divided by 2a. So remember, your formula or your quadratic is written ax squared minus bx plus c. So we take our b value and our a value and we plug it in. So my b is -4, so it's going to be -4, or the opposite of -4, which is +4, and 2 times negative 1, because if you don't see a number, it is 1. The leading coefficient would be 1. So then I simplify that and solve that for what x is equal to. So negative times a negative is a positive, so that's 4 divided by negative 2, which equals negative 2. So my line of symmetry is at x equal negative 2. So I go over to negative 2 on my x-axis. And remember, at this point, I just know that's my line of symmetry. I don't know what other point, but I do know that somewhere on the line of symmetry is going to be my vertex. So to find that vertex, I'm going to make a table of values. And what I want you to do when you're making your table of values is I want you to, there's x, y, do 2 points on either side of your vertex. So I'm going to do negative 2 here because I know my x value is negative 2. That's what I found here. I have to find my y value. I'm going to do that by plugging it or substituting it back in to this equation. So y equals negative x squared. X is negative 2 squared minus 4 times negative 2 plus 7. So when I simplify that out, now guys, be careful here. If you have a leading coefficient of negative, only the x is squared, not that negative. So it's going to be negative 2 times negative 2, which is positive 4, but I still have this negative out front, which makes it negative 4 plus 8 plus 7, which equals 11. So my vertex is at negative 2, 11, which is going to be about right there. So that's my vertex. Now remember that your graph is going to be this identical on both sides of the line of symmetry. So here my y-intercept is right here. So I know that there has to be another point equal distance on the other side from my line of symmetry. So I can automatically plot that point, which is at negative 4, 7. So I know negative 4, 7. So I'm just going to go over 2 more and land at negative 6 and find out what my y value is going to be when my x is negative 6. So negative 6 squared minus 4 times negative 6 plus 7. So here my y value is going to be negative. Remember, 36 is positive. Negative times a negative is a positive, but I have a negative on the outside. Negative 4 times negative 6 is positive 24 plus 7. And when I solve that out, I get negative 5. So I know at negative 6, it's going to be negative 5. So if I go over to negative 6, it's negative 4, negative 5, negative 6, I'm going to go down 5. And without finding the other point on the other side, I know there has to be a point equal distance from the line of symmetry. So it's 1, 2, 3, 4 from the line of symmetry at negative 5. So I'm going to go 1, 2, 3, 4 at negative 5 on the other side to find my other point. So when I draw my parabola, it's going to go through those points, and it's going to look identical on both sides. Okay, so I've identified my line of symmetry. I've identified my vertex, my y-intercept. Let's write that on the graph, y-intercept. And I also need to identify my zeros. So here's a 0, here's a 0, or my x-intercept. So this is x-intercept, this is a 0, or a solution. And yes, I want you to write all 3 because I want you to know that each one of those represents the same points on your parabola. Okay, so let's look at this and graph this one. So I'm going to start with my y-intercept. Remember, that's your c. There's no b because there's no bx value. So my y-intercept is 0, -4. So I'm going to go up here, 0, -4. That's my y-intercept. So I know it's going to be somewhere on my parabola. I just don't know where yet. We're going to figure that out. So now I'm going to find my axis of symmetry. And remember, this is a formula that's given to you on your formula chart. So the formula says x equals the opposite of b over 2a. So the opposite of b here is 0 over 2 times 1. Well, 0 divided by anything is just 0. So I know x is equal to 0. So when I plug that in here, y is going to equal -4. So my vertex, my line of symmetry is at 0. So this is my line of symmetry. My y-axis is my line of symmetry. And my vertex falls on the line of symmetry. So my y value, so my vertex has to be 0, -4, because my line of symmetry is at 0, and my y value, where my line of symmetry happens, is -4. So this is not just this is my y-intercept, but it is also my vertex. So I know that my graph is going to go up because this is positive. So I know it's going to branch out. So here, and we'll talk more about a being positive. So I'm going to go over here. I have y equals x squared minus 4. And I want to find a table of values to graph my parabola. So I already know in the center is 0, -4. So I'm just going to go out one step on each side. So -1, -2, 1, and 2. And I'm just putting in some x values so I know which direction to go. So I'm going to start with +1. So 1 squared minus 4, y is equal to -3 when x is 1. When x is 2, y is equal to 2 squared minus 4. So 2 squared, 4 minus 4 is 0. So y is 0 when x is 2. So I can plot those points. So I go over 1 up 3. And then I go over 2 and up 0. And that doesn't look right, and I realized I forgot my negative here. So this point should actually not be at +3, it should be at -3, right here. So remember, our line of symmetry splits it in exactly half, so I have to have a point right here, and I have to have a point right here. So I'm going to draw my parabola through those points. Okay, I've got my line of symmetry, my vertex, my y-intercept, and it just so happens that these points right here are also my x-intercept, my zeros, and my solutions. Okay, so that is how you graph and then identify your key features of a quadratic. Okay, we're almost done. Let's do one more graph. What I want you to do, this is already graphed for you. Turn off the video, pause it, and I want you to look at this parabola, and I want you to identify all of your key features, and then turn it back on and see if you've labeled them correctly. Okay guys, so check it out, see how you did. We will continue practicing graphing parabolas. I will also show you how to use your calculator to help you with that as well. But I want you to be able to do it by hand as well as with the calculator. So ask me if you have questions. Main focus here is making sure you understand your key features and how to find them. So check out your Edpuzzle questions, ask me questions, and then work on skills check. Thanks, guys.